Atomic Spectra from class 12, practice MCQs test, specifically designed keeping in view the syllabus for MDCAT, and also helpful for all these institutes in the engineering admission entry tests. Quickly, we start with the first question. The first 10 questions have been based upon the conceptual and theory based. The first question here is: the line spectrum of hydrogen atom provides evidence that the nucleus is positively charged, electrons move in circular orbits, energy levels in atoms are quantized, and electrons are revolve randomly. So out of these four statements, the option C is the correct option, that energy levels in an atom are quantized. Recently, these kind of identifications also been carried out in the Nobel Prize for Physics 2025. I will make also a video regarding this. Next question here is: which statement best describes the emission spectrum of hydrogen atom? Options are continuous spectrum, discrete lines of specific wavelengths, broad bands of colors, and uniform distribution of light. Out of these options, the correct option is the discrete lines of specific wavelengths. The next question is that when an electron jumps from a higher to lower orbit, energy is absorbed, released as a photon, converted into heat, and lost in collision. Here the correct option is the release as a photon, and actually this can be written as that the delta E, which is the gap or energy difference between these two levels, like if I say that this is E2 to E1, so that will be equal to HF, and it can also be written as HC by lambda, where F is the frequency and lambda is the wavelength. The next question with us is the energy difference between two adjacent energy levels in an atom. Options are remains constant, decrease as n increases, increases as n increases, and depends on temperature. So out of all these, the correct option is the option B, because as the n increases, the energy gaps shrink. So that the option B will be the correct option. Okay. The next question is the Balmer series lies in the infrared region, visible region, ultraviolet region, and X-rays region. So this should be clear that this lies within the visible region. So the correct option is option B. The next question with us is the Lyman series of hydrogen corresponds to transition ending at n is equal to 1 to 2. The options, the second option is 2, the third is 3, and the fourth is 4. I mean by A, B, C, D. And this actually corresponds to n is equal to 1, which is the first option. And another information we should also know that this region or the emission spectrum lies within the ultraviolet region. The next question is: in Bohr's model, the angular momentum of the electron is quantized because only certain orbits are allowed. It depends on radius of atom. It equals nh by 2 pi and both A and C. So first of all, this should be considered that it equals nh over 2 pi. So basically, this is the mathematical expression which we have for the angular momentum, which is nh by 2 pi. So the option C is a correct option. Also the option A is correct one, because it only certain orbits are allowed. So that is the option A is correct also. So both option A and C. So based upon these two options being correct, the option D will be the final correct option. So anyone who just picks A or C, that will not be the correct option. Okay, so the next question is when white light passes through a hydrogen gas, the observed spectrum is emission spectrum, the absorption spectrum, continuous spectrum, infrared spectrum. As it is passed through the hydrogen gas and the observed spectrum, we will get the absorption spectrum. But we should keep this thing in mind that gas absorbs its own characteristics frequencies. So that gas will absorb a specific number of frequencies, not all the frequencies, but the spectrum we will get the absorption spectrum. The next question is, according to Bohr, the radius of an orbit is proportional to n square, 1 by n and 1 by n square. So here we have that Rn is directly proportional to n square into that Bohr's radius formula. So let's say if I just I'm just writing this equation, so this proportionality will not be there, we will have an equation. But actually I have shown here that the radius actually depends upon the n and n square. So you increase from 1 to 2. So let's say if I put just first value, so 1 square will be equal to 1, but 2 square will be equal to 4. So for the second n is equal to 2, the main Bohr's radius formula will be multiplied by 4. So here the correct option is option B. And then we have the question number 10. The spectral lines are sharp and discrete because electron energy levels are discontinuous, electron energy levels are quantized, atoms vibrate randomly, light has dual nature. So that is actually the quantization effect. So the option B here will be the correct option. I will mark this. Now coming towards some calculative and numerical MCQs, because we have also to face these kind of MCQs. So the first question is, the Rydberg constant R has a value. So this is just a kind of memory type question. And here the correct option is the option A, 1.097 into 10 raised to power 7 per meter. Question number 2, the 12. The wavelength of the photon emitted when an electron jumps from 3 to 2 in an hydrogen atom is approximately, the options are given. So this can be easily calculated by the equation. So it can be easily solved by this formula. And the correct option here will be lambda is equal to 486 nanometer. This needs a very simple kind of mathematics, I mean multiplication, so one can easily solve it. Remaining this portion can be easily solved. I can write it here as, so it can be easily solved as this portion as 5 by 36 and used to multiply with the R. You can get the value 486 nanometer. The next question is, the shortest wavelength in the Lyman series corresponds to a transition from 2 to 1, 3 to 1, infinity to 1 and 4 to 1. So here the correct option will be the infinity to 1, because it has a shortest wavelength to have a highest frequency. So this will be the option C. Question number 14 is, calculate the wavelength in nanometer of a photon emitted when an electron in hydrogen jumps from 4 to 2. R is this value, so it can be easily calculated again with the same equation as I mentioned in the previous equation MCQ, and the correct option will be here as 434 nanometer. Sometimes the option may be very closer, the options may be given like the closer options, so one can go with this rounding of the values. The same is the question number 15. The energy difference between n is equal to 3 to n is equal to 2 is, again, it's very simple. E is equal to h c by lambda. So here the correct option can be easily calculated. Well, first of all, find the lambda and then this value. Although sometimes the students may think that these kind of questions need calculator, but one can say that, let's say if I am just writing an equation, so these equations can be easily solved, like this portion can be easily solved and just multiply with the r, and maybe the options are given in a product form, so one can easily get the value. Similarly, in here, the energy of a photon of wavelength 434 nanometer is approximately. So again, we can use this equation. So putting this value of lambda here, we can easily find out the equation, the value. Already you know the Planck's constant value, the C value. So these kind of smaller calculation will be helpful to understand, because sometimes the numerical questions are there in the test and the students are unable to solve it. So one should go with these small type of calculation. So due to that practice, the students will feel easy whenever they are facing numericals like this. Okay, so in the next question, for a hydrogen atom, the energy of electron in the first orbit n is equal to 1 is 13.6 minus 13.6. So it's very simple one, as you know that it is equal to 13.6. So the option B will be the correct option, minus 13.6, not the positive value. The next question is the frequency of light emitted during a transition from n is equal to 2 to 1 hydrogen atom is approximately. Again the same calculation, but this time the frequency is required, so we will have to switch over the result and one can easily find out the value. This is the equation where first of all one finds the energy, or it can also be done as F is equal to C by lambda. So first of all calculate the wavelength and then find out the frequency. Whichever is easier, you can go with that. Okay, so the next question is the wavelength of a photon emitted when an electron transition from 5 to 2 lies in which region? Ultraviolet, visible, infrared, microwave. So here we will have the correct option as the ultraviolet photons. Okay, this one. So this is the correct option. And finally the question number 20 here is that if the energy of an emitted photon is 2.55 electron volt, the corresponding wavelength is approximately. Again we have the same equation, E is equal to hc by lambda. Switching over these values, lambda is equal to h c by E. So just put the values of E and one can easily find out the h and c values. They are already constants. So these values, approximated values, can be easily calculated, and here you will find that it is 486 nanometer. The correct option is option number B. I hope so that during this 20 questions practice, you must have got something about the questions which will be in the MDCAT test or another entry test series. If you find any kind of difficulty or you need any help in this regard, just please comment, share with your friends for maximum support to the others. Thank you.